In this video, you'll learn all about further maths and why you should study it, and some of the things that you'll learn during the further maths course. You'll see some pictures of some books here. These are actually the books that you'll study over the 2 years, 4 of them. A picture of the different types of calculator that you can get as well. So what is further maths? Well, it's an additional A-level. You do it in addition to further maths. Normally it's your 4th A-level alongside the other 3. It's really designed for top students in maths. Although you are asked normally for a grade 7 or above to do A-levels for further maths, really a grade 8 or 9 is preferred. You need to be someone that really enjoys maths, you really enjoy a challenge, you enjoy algebra, problem solving, all that sort of stuff. And it's not necessarily for people who are considering studying maths at university, although that would be great if you did that. It can be for people that are looking to do related STEM subjects. So whether it's a science subject, technology, or engineering subject, further maths will give you a step ahead of all other students that are not studying it. So what type of pure maths is covered in the further maths course? Here's a couple of examples of some topics that are covered. So complex numbers, and we're going to do a couple of examples of some complex numbers problems. Complex numbers are used extensively in things like engineering, when engineers are working out what we call the phase angle of electricity through circuits. They'll use complex numbers, has lots of other applications as well. Matrices is another topic you'll be using and learning about. This is used extensively in computer animation, where they can manipulate matrices, which are like really big grids of numbers, and they can use these to create animations quite easily using matrices. So all about the specification. We follow the Edexcel exam board, and whichever exam board you do, you will have 4 exams. Now 2 of those exams are what we call compulsory. So we have here Core 1 and Core 2. Now these exams you need to study whatever other units you do, and then we have a choice as to the other units that we do. Now the other units that we do are further statistics and further mechanics, FS1 and further mechanics 1. There are other options like decision maths or further statistics 2 or further mechanics 2, but by doing some statistics and mechanics, it gives you a well-rounded further maths A-level. You get to do like a little bit of everything, which is more useful for you when you move on to university. Each one of the exams that you sit in each one of those modules is an hour and a half long, and it's worth a quarter, 25% of your final mark. Each exam carries 75 marks, so your further maths A-level will be out of 300. So what's the content? Well, if we start with Core 1 and Core 2, we've got lists of topics there that you would do. Now, most of those, in fact, probably all of them, apart from the word algebra, will all be new to you. So algebra and functions, you probably would have seen these words before at GCSE, but all of the other topics will all be new to you. You've also probably done a little bit of proof. In FS1, which is the further statistics module, you'll be looking at lots of different what we call distributions, lots of tests that we can do on data. And in mechanics, there's quite a big overlap with physics. So if you're doing physics, you'll find that some of the content you'll study in physics, like momentum, work, energy and power, collisions, that type of thing, also overlaps with physics as well. So assessments, well, we do an assessment every half term. Every half term you'll have assessments. You may have mini assessments in class as well. All your exams, your 4 exams, will be at the end of year 13. And as said before, the papers are an hour and a half long, so an hour and a half paper on core 1, an hour and a half paper on core 2, and the same for FS1 and FM1. And as said before, each one of these exams is worth 75 marks. So, typical lesson. Here's an example of one of the first topics you'll be learning, and that's about complex numbers. And a complex number is made up of what we call a real part and an imaginary part. So we have a real part and an imaginary part to a complex number. Now, you may be saying to yourself, well, okay, what are these? How can it be real? How can it be imaginary? Well, real part of a number, these are numbers that we've been used to dealing with. So these could be positive numbers, they could be negative numbers, they could be fractions, decimals, recurring. So all the numbers that we've been used to dealing with so far. Whereas an imaginary number, these numbers are based on the square root of -1. Now, why do we need the square root of -1? Well, you've probably had equations in the past where you've tried to solve something like this. Solve, let's say something like x squared equals -16. Now, as it stands, you've never been able to solve that. Yeah, because no number squared gives you a negative number. But we can use the letter I to stand for the square root of -1. Now, imaginary, where did the name imaginary numbers come from? Well, it was sort of made up because people thought it was silly. They thought, well, you've got these imaginary made up numbers, and the name has stuck, really. So let's have a look at a couple of examples here. So here we've got, we're working out the square root of -36 in part A. Well, we know the rules for power say that I can write this as the square root of -1 times by 36, which is the same as the square root of, I'll just change the order, 36 times the square root of -1. Now the square root of 36 is 6, and the square root of -1 is I. So here we're able to find the square root of a negative number. Let's try another one here. We've got the square root of -28. So we're going to do the same thing again. And we're going to say, right, this is the same as 28 times by -1. That can be split up into the square root of 28 times the square root of -1. Now, we should know that the square root of -1 is I. And the square root of 28, well, we can write that as the square root of 7 times the square root of 4. So we've basically got this here. So this becomes 2 root 7 I. So you've solved your first problem to do with complex numbers. So here's a problem here. We're going to solve it. It's a quadratic equation, but it doesn't factorize. So we're going to use the quadratic equation, which is -b plus or minus the square root of b squared minus 4ac. So you're used to seeing this. You've seen this before. Now, if I use the quadratic equation on this, a will be 1, b will be 6, and c will be 25. So all we're going to do now is to plug those numbers into the quadratic equation. So we'll have -6 plus or minus the square root of b squared, which is 6 squared, minus 4 times a times c all over 2a. So this is what z equals. Now you'll see z rather than x in equations where we're dealing with complex numbers. So z, but we solve it in the same way. So what do we get from here? So we've got -6 plus or minus. Now underneath the square root you'll have 36 minus 100. 36 minus 100 all over 2a, so that's 2 times 1, which is just 2. So we'll have -6 plus or minus. Now we have a problem here. If I do 36 minus 100, I get -64. Now in the past that would have been a problem, but not now. The square root of -64 we can write as 8i. So you can have a little think about that. And why is 8i? Based on the stuff that we've done before. So from there, my final answer would be that the solution to this equation, z, is equal to, and I'm going to divide them by 3, and I'll get, by 2, and I'll get -3 plus 4i, or z equals -3 minus 4i. And what you might want to do as a bit of extension is multiply them by themselves, or put those solutions back into the original equation. Put those solutions into here. See if you can work out why this works. So if you put this back in, do you get 0? So if you put one of these in here, this one, or this value of z, see if you can get it to give you 0 when they're put into that equation. Here are some quotes from students. The next few slides show some ideas of future pathways. So here's some extra resources. If your son or daughter really loves maths and they want to be stretched, there are 4 ideas there which they could do. If you want to find out more about further maths, best thing to do is to speak to your maths teacher, or here are some websites that will give you lots of information about studying further maths and why it will be really, really useful for you to study further maths.